Hi, this is Mr. Miller, and in this video, we're going to solve the practice mastery quiz for probability rules. All right, here we go. The first part of the test begins with this. It says, a student rolls a six-sided die. What is the probability of rolling a number that is less than or equal to 2? So when we roll a six-sided die, six things can happen. We can get the numbers 1, 2, 3, 4, 5, or 6. And the probability of rolling a number that is less than or equal to 2 would be the probability of getting these two numbers. So it would be 2 out of 6, and if you want to reduce it, that would equal to 1/3. All right, for number 2, it says if a normal six-sided die is rolled 2,400 times, how many times would you expect to get a 4? Well, the probability of getting a 4 is 1 out of 6. Okay, that's the fraction of time we expect to get a 4 when we roll the die many times. So if we roll it 2,400 times, we'd expect 1/6 of those to be 4s. So we can find 1/6 of a number by multiplying by 1/6. And if you use your calculator and do 1/6 times 2,400, you'll get 400. All right. Let's scroll down a little bit. For this one, we have two sets, A and B. We want to find the union of the two sets. The union is what we get when we put the sets together. It's anything that's in set A, set B, or both. And remember, we don't list repeats. So I'm going to list the elements we have in set A. We have 0, 2, 4, 6, and 8. And I'm going to add to that the numbers we don't have already. So we don't have the 7 or the 9, so I'm going to include those. All right, this one we're finding the intersection of A and B. That's the set of everything that's in both sets that are in set A and in set B. The only number that's in both sets is 8. So we're going to just have a set with the number 8. All right. A card is dealt from a shuffled deck of cards. Suppose event F is defined to be the event that the card is a face card. Describe the complement of F. Well, the complement is the set of everything else. So this would be the set of cards that are not face cards. There we go. It takes me a little while to write. Okay, let's keep going. The next problem involves this card diagram, which you can see on the practice mastery quiz. And they ask the following questions about it. So A is the event, the card is an ace. So A is the event, we get one of these cards, an ace. And event B is the event, we get a club. So the clubs are these cards, the first row. Okay, we're going to do a bunch of calculations with these two sets. All right, so first is find the probability of A. That's the probability of getting an ace. Well, there are 4 aces out of 52 cards. And if you leave it like that, that's fine. 4 out of 52. That does equal 1 out of 13 if we reduce it. Okay, probability of A prime. So remember, this means complement. It means the probability we get a card that's not an ace. Well, there are 48 cards that are not aces over 52, and that reduces to 12/13. Okay, this is the probability of A union B. I'm going to scroll up again. That's anything that's in set A or set B or both. So we want to be careful not to double count this first card. So there's 1, 2, 3, 4. I've already counted that card, and this would be 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We get 16 out of 52. Okay, this is the probability of the intersection. It's in set A and in set B. There's only one card that's both an ace and a club, so this is 1 out of 52. Okay, now this is a probability of B given A. It means the probability we get a club given that it's an ace. So we're only looking at the aces, and there are 4 aces, and of the 4 aces, only one of them is a club. So the probability of B given A is just 1 out of 4. This is the other way around. This is the probability we get an ace given that it's a club. There are 13 clubs, and one of them is an ace. So the probability of an ace given a club is just 1 out of 13. All right. Well, it says, are A and B disjoint? The answer is no. So they have one card in common. Okay, which is the ace of clubs. What is the relationship between probability of A and probability of A prime? Well, this is always true, that the probability of A plus the probability of its complement is equal to 1. In this case, it's the fact that 1/13 plus 12/13 equals 1. All right, well, we're moving on in the quiz. We have this Venn diagram problem. So it says 120 pages of a calculus book were analyzed for their content. 74 of the pages had some kind of diagram, 93 of the pages had an equation, and 66 pages had both. So I said let D be the event that a randomly selected page has a diagram, and E the event that it has an equation. All right, so we have to fill out the Venn diagram here. We can't use the 74 or the 93 yet. We have to start with the part that goes in the middle of the diagram, that 66 pages have both. Now we can work backwards. It said 93 of the pages had an equation. So the total for this circle is 93. So if I do 93 minus 66, I get 27, which is how many pages are left here. So 66 have both a diagram and equation, 27 have an equation alone, and together these make 93. All right, 74 pages had some sort of diagram. Well, the total for this circle is 74. If I subtract the 66 I have already, that leaves 8. Okay, well, there's some pages that have neither. The book had 120 pages, so if I take 120 and I subtract what we have here, minus 8, minus 66, minus 27, I end up with what's left, 19. All right, so it says, what is the probability that a randomly selected page has a diagram or an equation? This means union. So it's this number plus this number plus that number. Together, that's everything that lies within either one of the circles. It turns out when we add 8, 66, and 27, we get 101 out of 120. That's the probability of the union. Okay, it says write an equation to describe the relationship between these probabilities. It's really just asking about the second law of probability, which has to do with unions. So the probability of D union E is equal to the probability of event D plus the probability of event E minus the probability of their intersection. So this is the general law. In our case, the probability of the union was 101 out of 120. The probability of D was 74 out of 120. The probability of E was 93 out of 120. And if we subtract the intersection, that would be 66 out of 120. And this equation is true. This shows the relationship for this problem of these probabilities. Okay, we have a table here. It says the table below describes the smoking habits of a group of asthma sufferers. The asthma sufferers were categorized as non-smokers, light smokers, and heavy smokers. Their gender was also recorded. Okay, so it says suppose an asthma sufferer is randomly selected. That means we're picking one person randomly from all 1,139 people. So it says, what is the probability that the sufferer is a non-smoker? Well, here we have the total for non-smokers. This is 634 divided by the total number of people in the table, 1,139. And if you divide this, you actually get 0.56. Okay. Second question, what is the probability that a sufferer is a non-smoker given that they are a female? So we're only looking at this row, the females. So there are 330 non-smokers out of a total of 680 females. And this is equal to 0.48, or actually 0.49. Okay, it says, is the event that a sufferer is a non-smoker independent of the event that are female? Well, it turns out that this condition that they're a female mattered. This is the probability of getting a non-smoker. This is the probability of getting a non-smoker given that they're female and they're different. So they are not independent. Okay, here we go. So we're near the end here. It says you roll you should say you're dealt 3 cards with replacement from a deck of cards. With replacement means that each time you're dealt a card, it's put back in the deck and shuffled again. That means the cards are independent, all right? Whatever you get for the first card is not affecting what you get for the second card. So determine the probability of the following events: that you get 3 hearts. Well, this is the probability that the first card is a heart, and the second card is a heart, and the third card is a heart, which would be 13 out of 52. That's the probability of getting a heart, times 13 out of 52, times another 13 out of 52, and that ends up being 0.016. So there's a 1.6% chance of that happening. The third card is the first heart that you get. That means the first card is not a heart, and the second card is not a heart, but the third card is. It's the first card that actually is. And this time, if you multiply all this out, you get 0.14. So 14% chance of that happening. All right, none of the cards are hearts. Well, so it would be the probability that the first card is not a heart times the probability the second card is not a heart times the probability the third card is not a heart. They're all the same there, 39 out of 52. And that ends up being 0.42. Pretty good chance of that happening, that if you're dealt 3 cards, none of them will be hearts. All right, about 42% chance. All right, so here we go. The last question. The first card is a face card, and the next 2 cards are not. So, okay, well, this is the probability that the first card is a face card, and the second card is not. So it's the complement, and the third card is not. Well, there are 12 face cards out of the 52 cards, and 40 of them are not face cards. So we get these 3 fractions. Okay, well, when you multiply them together, you get about 14%. All right, and that's the end of the practice mastery quiz. So hopefully this helped. Please be sure to ask your teacher for questions if you have any, and good luck on your quiz.